So what are attack paths to compromise a Linux host? It's also very similar to what's going on with Windows. It's still password guessing of different services. SSH, for example, is really slow, but still can be password guessed. SMB comes with Linux sometimes. Different internet services like mail transfer agents or mail catalogs or different web applications are also normally run on Linux. And the funny thing here is that there are application accounts created for each of them. Yeah, so for example, there are daemons that runs within some abstract user account environments like nobody, like username nobody and group name no group. Yeah, there are cases like that, but normally they just have some users created for them specifically, and these users, these virtual users, own their working directories. For example, if you run a Apache Tomcat application server, right, that is normally used to deploy Java applications on the server, it has Tomcat user in the Linux operating system, yeah, and everything you deploy there is placed into the root catalog, into its document root, with permissions of this user, right? So if you have access to Tomcat and you can compromise its management console, you basically can upload any executable code up there, and it will be run with Tomcat permissions. So you will have access to all other applications installed into this Tomcat instance. Okay, so this is like the limit of your abilities to exploit a specific user account. So you will be having access to everything created or possible to be read by this user account. Okay. What about remote exploitation? It's also almost the same. Binary code has different execution formats, but still there are code pages, there are data pages, data segments, code segments, and so on. So smashing the stack and exploiting heap corruption are on the principle level really similar. However, the exploits are normally different. So if there is a logical flaw in input control for the same application that can be compiled and run on both Linux and Windows, you most probably will be able to exploit both of them, but with slightly different exploits. Okay, so it has differences in particular methods, but the approaches are pretty much the same. Okay. What about local privilege escalations? So again, there are cron jobs that can be run from a different user. There are sometimes, if they are not fixed yet, that could be possible. There are kernel exploits. There are file system driver exploits that can be locally compiled and exploited. That looks really dramatic on Linux, much more dramatic than on Windows, because on Windows you meet these cases on almost the monthly basis until recently, yeah. But in Linux, it's really a big news all the time. If you find the local privilege escalation in Linux kernel, it makes headlines on hacking forums at least, and it looks like you compile a binary and then you run it, and then suddenly you find yourself in the root shell. Yeah. So instead of this $sign that is normally meaning that you run the console session as a normal user, you have this pound sign, yeah, this hash sign that represents the root user session. Okay, so rootkits are the things that are deployed by malicious hackers in order to first get control over Linux machines, and second, to hide their presence. Okay, these are slightly more prevalent on Linux. Yeah, so Windows doesn't have this notion of rootkits normally. Yeah, so there are backdoors, but rootkits, because the etymology shows that it's coming from somewhere where root is is a thing. Yeah, and this is Linux most probably. So what rootkit contains of? So it's most probably a bunch of binary tools, that represent that substitute legitimate tools. For example, there should be a copy of PS program that normally shows the processes in memory that are run right now, with different security related information. But a decent rootkit would rewrite this PS program in order to filter out that portion of output, that discloses the actual presence of the rootkit. LS program that shows the contents of the directory, or shows specifics on a given file, also most probably will be rewritten in order to filter the information about the rootkit elements and so on. So rootkit will give a remote attacker like the persistence in the system. So they will have to come back sometimes, and if the configuration of the system changes, like the user they have compromised changes their password or something else happens, they will have to access the system somehow, and this is where the rootkits are used basically. And they fix this state of compromise. They preserve this level of compromise that attackers have achieved in the attack. Okay, so this is what rootkits stand for, and they are massively used in Linux. And any network worm that relies upon brute forcing some well-known SSH passwords, for example, will rely upon rootkits for propagation and arranging persistence in the system. You can meet that. You can actually artificially create that situation. If you put a box that you are if you are in control into the internet, and you deploy some kind of a honeypot, this is the specific tool that imitates some legitimate services, normally not very well configured ones, like allowing access with some very basic and simple password as a root user. You will, in a few days, I guess, that's the maximum that you will last without attention from these network worms, you will find yourself a victim of attack attempt. And if everything goes well, you will just be like virtually compromised by a bot, by a worm that is totally automated. It will just come to your port TCP/22. It will try out root with the 10 most popular passwords at the moment, and maybe it will just get in with username root and password, and then you will see in this honeypot will register the further actions of this worm. And first thing it will do, it will deploy this rootkit, and then it will just deploy its payload. And this payload will be undetectable after the rootkit is successfully deployed, if it is. And then the payload will start scanning the internet for other machines having port TCP/22 open, and will try to probe the passwords they have against those machines. So That's what normally happens in the real world, and by installing honeypot you can actually observe what the bad guys do. That's a really interesting thing. Of course, if you have a sophisticated attacker that performs manual operations, in most cases they will detect the honeypot in the early stages of attack. But if it's an automated network form, most probably you will just see how it works. Okay, and even if you don't want to run a honeypot, you most probably can see a lot of different login attempts into your SSH server and your access logs in any machine that is running on the internet on Linux. Okay, so what's the actual difference of attacking Linux and Windows? Because until now it was more or less the same thing. So remember that just historically, out of its I guess cultural specifics, Linux is much more secure than Windows. Not because it contains less vulnerabilities, which I strongly doubt. The factual security, right? The actual lack of known vulnerabilities to attack Linux is a result of its relatively low popularity. Okay, so over the years, these operating systems like Linux or Mac OS or different flavors of Unix were attacked when either a public vulnerability emerged and everyone quickly knew about it, or it was the target of a really sophisticated targeted attack. Okay, so if an attacker was really dedicated to their success, it was possible to hack into Linux as well. But no one really bothered because the monetary value of Linux compromise was relatively low. Because the monetization of a Windows worm is a real thing. And how many Linuxes are out there? Up to 5%. Not interesting. So the bad guys were mainly focused on Windows, and the penetration testers and ethical hackers did that too. So that's what the history was. Now Linux becomes more and more prevalent on in the business world. It's installed on many machines more than previously, and the Mac OS becomes very prevalent as well. So maybe this state of affairs, this status quo, will somehow shift towards Linux and Mac OS, but until then Windows will still be more quote-unquote vulnerable. Okay, so unfortunately that's the fact. Microsoft somehow deals with that. They are not the leader anymore in number of vulnerabilities disclosed within 1 year, but still that's the fate they have to live with. So we will definitely focus more attention on how to compromise Windows, but we have to know how Linux works and how to compromise that as well once we get a hold of a zero-day vulnerability, yeah, before we sell it to some shadow vulnerability broker. I'm just kidding. Reported to Linux community.